Welcome back, Honors Algebra 2 students. Mrs. Fellon, we are on page 249, Student Journals, and we are talking about lesson 9.2. So there's going to be a lot of stuff in this section, and so I want to try to make sure that I explain it as thoroughly as possible, but also you may have to kind of, digest some of this stuff as we go along, write down any questions, that kind of thing. You're definitely going to need a calculator as well as some paper. So just so that we can kind of do some additional stuff that maybe is not in the student journals. All right, so we're going to start on page 249 because what we're going to kind of walk through is just some of our terminology. So the first couple things is talking about how we label or talk about angles. So probably up until now, other than you really haven't dealt with angles that are greater than 180 degrees. And now we're going to kind of talk about using the whole circle and recognize that a circle is 360 degrees and that we can represent angles anywhere from 0 to 360 and beyond. We can talk about negative angles, we can talk about positive angles, we can talk about angles that are more than one revolution around, which means it's more than 360 degrees. So the first and foremost, when you talk about an angle, and we're talking about initial side and terminal side, there are some words that kind of come up here. So when you measure an angle, you use the x-axis, and this is called our initial side. And so basically our x-axis is kind of like our starting value for our angle. Where your angle ends up, so like in this case, if I say I'm going to do an angle in quadrant 2, so I measure from the x-axis. Notice that that my angle, the vertex is at the origin. This would be an angle that lands in the second quadrant, and we measure it from the x-axis to wherever this last ray ends. And so we call this ray over here the terminal side. So an angle that's like this, okay, so what I mean by that is an angle that has the initial side on the x-axis, and then the terminal side is in one of the quadrants, whether it's in quadrant 1, remember this is quadrant 1, this is quadrant 2, down here would be quadrant 3, and down here would be quadrant 4. So your terminal side could really land anywhere. And so that's how you measure an angle, from the x-axis backwards. We call this counterclockwise. So we measure it counterclockwise. So you're going to measure the angle counterclockwise. And so basically that just means you're starting with the x-axis and going to kind of to your left. When an angle is in standard position, it means that the vertex is at the origin. So the vertex is at the origin, kind of like the way I did my example here. The initial side is on the positive x-axis, and the terminal side is in, one of your quadrants, or it could be on your x-axis or your y-axis, and we'll talk about that in a minute. So that's how you kind of measure an angle. The next thing I want to talk about is something called coterminal. So coterminal means that because we're not just limited to 360 degrees, we're not just limited to one revolution around. We can keep going and going and going and going and going. So like for example, if I go all the way around here, I get 360 degrees. If I do another lap all the way around, that's 720 degrees. Those angles, the 360 and the 720, would be considered coterminal. It basically means that two angles that end in the same position. So let's take this example here. Let's say this was an angle that's 120 degrees. Okay, so we know that this is 0 degrees, this is 90 degrees, right? Your right angle. A whole straight line, so all the way across would be 180 degrees. And then we know, or maybe you don't know, but this is 270 degrees, and then we're back to 360 degrees. So if we were measuring an angle, we'd start at 0, 90, 180, 270, back to 360. And then we could keep going by multiples of 90. And so anyways, what we're talking about here is, let's say we have an angle that's 120 degrees. So it's out of the first quadrant, it's in the second quadrant, it's between 90 and 180. A coterminal angle to that one would be any angle that's then going to look the exact same. So in other words, the initial side is going to be the same, the terminal side is going to be the same. The only difference is it's going to be one revolution around. So in other words, we would add 360 degrees. So a coterminal angle to 120 degrees would be 480 degrees. So 120 and 480, if you were to draw them, okay, they would both look like the same exact angle. The only difference is that you would go one complete revolution around in order to get to the 480. So the angle itself looks the same. The only difference is that it's one revolution around. So we call any angles that are in the exact same position like that, we call them coterminal. Now you can have coterminal angles that go the other direction. So remember what I said, when we measure an angle, we measure it counterclockwise. Well, when we measure an angle clockwise, so like for example, if this is 120 degrees, if I went the other direction around my circle, okay, so I'm going clockwise. In other words, I'm going the same direction a clock would go. So if I start at x, or at my x-axis at 0, and go this direction, this would be an angle that's negative, okay, 100, or I'm sorry, negative 240. So why it's negative 240 is because I'm going backwards 240 degrees. So 120 degrees and backwards 240 degrees is also going to give me the same exact angle. I'm going to land in the same spot. So a negative angle means you're going the opposite direction. So a negative angle just means that you're going, instead of going counterclockwise, you're going clockwise. So another way to get a coterminal angle is to subtract 360 degrees. And so if we did that, so if I subtracted 360 degrees, I get that negative 240 degrees. So not only is 480 degrees coterminal, but so could negative 240 degrees to coterminal. There are infinite number of coterminal angles for any given angle. So what I mean by that is, if I took my same example of 120, I could keep adding 360 to get as many coterminal angles as I would like. So 840 is another coterminal angle. Likewise, I could keep subtracting 360 from 120 and keep getting a whole bunch more coterminal angles. All of these angles that are coterminal are going to look and end in the same spot. So they're all going to kind of look like this type of an angle. So you can have an infinite number of coterminal angles. That's kind of what we're getting at here, an infinite number of coterminal angles. All right, so one of the other things that we're going to talk about in this unit is we're going to get into this idea of what is a radian. So a radian is, you've dealt with angles that are in degrees, right? We've talked about, in geometry, we've talked about, angles in degrees. In algebra 2, obviously, now we're talking about angles that are in degrees. What we're going to kind of talk about now are angles that are in a different unit of measure called a radian. And so angles that are different unit of measure called a radian, what we're going to do is I'm going to show you how to measure an angle in radians. So you might have noticed on your calculators, when we changed our calculator to degree mode, there was that other option that said radian. And that's because there are two different ways in which we can measure angles. We can measure angles using degrees, and we can measure angles using radians. And so depending on what we're asking for depends on what unit of measure. It's kind of like measuring, like if you were measuring the length of something in inches versus centimeters, right? It's a different unit of measure. So what I want to kind of talk about first is kind of what is a radian. And so I'm going to grab a sheet of paper here just to kind of, I'm not going on a tangent here, but just to kind of explain this in a little bit more detail. So first and foremost, the reason why we know that, all the way around, let's say I did a circle. It's not a great circle, but let's say here's my circle. All the way around this circle is 360 degrees, right? So I go all the way around this circle, and I get to 360 degrees. Well, what do we call that measurement that's all the way around a circle? What do we call that distance all the way around a circle? You might have remembered it called a circumference, right? So think back to geometry, you're probably in middle school. The circumference of a circle is 2 pi r. That's kind of our formula. Or you might have seen it called pi diameter. Same deal. What we're going to kind of refer this to is we're going to talk a lot in this class about something called a unit circle. Okay, so a unit circle means it's a circle with a radius of 1. Okay, so it has a radius of 1 unit. So when we're measuring radians, what a radian is the measure of the arc. So if you remember in geometry, we talked about like arc length and arc measure. So we're talking about what piece of the circle represents. Like if I said I'm going to measure, let's say 30 degrees. So roughly here's 30 degrees, okay? And let's say I drew a circle all the way around like this. Imagine that's perfect. What a radian is the measure of this piece of the circle, okay? So it's a part of your circumference is really what it is. So obviously the circumference all the way around is 360. This measurement here, we could call this 30 degrees, or if we measure it in radians, we're basically referring to the length of that arc. So what I'm getting at here is if we have all the way around 360 degrees, right? And we're talking about a unit circle, which means our radius is 1. I'm going to plug 1 in for r. That means 360 degrees equals 2 pi. So this is kind of how we're measuring this. So the length all the way around of a unit circle is, rather than calling it 360 degrees, we would call it 2 pi. So why that's important is because now we can use, instead of thinking of this as 360 degrees, if we think of this as 2 pi, we can kind of think of our measurements of our angles. So for example, okay, so here's my circle all the way around, right? So this is what we call our unit circle. And we know, I'm just going to write, 0 degrees, 360 degrees, right? We know this is 90 degrees. We know this is 180 degrees. And we know this is 270 degrees, right? So it's every 90 degrees. Well, if we also know, instead of degrees, if we call this radians, this is 2 pi. So all the way around a circle would be that circumference of a unit circle is 2 pi length. Well, then what would halfway around the circle be, right? So what would 180 degrees be? If 2 pi is all the way around, then halfway around would have to be pi. Okay, so let's think about it this way. So now if we know this is 2 pi all the way around, and then this is pi, what's half of a half? Well, we'd get, half of this pi would be pi over 2. So imagine this being, we'll call this 0 radians. So 0 is 0, whether it's radians or degrees. And then we go all the way around is 2 pi, halfway around is pi, and then half of that would be pi over 2. So basically what we're getting at here is every 90 degrees, we're talking about pi over 2. So pi over 2 is the equivalent, the radian measure to represent that angle. So if this is 1/2 pi and this is 1 pi, this would be 1.5 pi. So again, all we really did here is just kind of use this idea that a circle is 360 degrees, or in other words, a whole circle is 2 pi radians. So 2 pi radians. And so that means half a circle would be pi radians, a quarter of a circle would be pi over 2, and then 3/4 would be 3 pi over 2. So when we do this, what we can do then is we can use any measurement on the unit circle to help us figure out the radian measure. So what we're going to get at is we're going to specifically look at the unit circle, but we can look at other degrees of angles that are not on the unit circle. So what I mean by that is we're going to talk about specifically about the unit circle where this radius is 1. And so all of the angles that are going to fall on my unit circle are going to be one of the ones that we're familiar with. And so what I mean by that is, remember those special right triangles? We're going to talk about a 30-degree angle, a 45-degree angle, and a 60-degree angle. So we're going to talk about that 30, 60, 90 triangle and that 45, 45, 90 triangle. So what I'm trying to get you to realize is, like, let's say, for example, this represents 30 degrees on the unit circle. How would we represent that in radians? Okay, well, how much is 30 degrees of 90? Well, isn't 30 degrees a third of 90, right? So there's 30 degrees in 90 degrees. So this is 1/3. So what's 1/3 of pi over 2? Let me rephrase that. What's 1/3 of pi over 2? So think of it as a multiplication problem. Since 30 degrees is 1/3 of 90 degrees, then for radian, this radian measure would have to be 1/3 of pi over 2, which would equal, if you do your math here, multiply across top, multiply across the bottom, 30 degrees would give me pi over 6 in radians. So the equivalent measurement for 30 degrees would represent pi over 6. Okay, same thing with like the 45 degrees. 45 degrees is half of 90, right? 45 degrees is half of 90. So if this is 45 degrees, the radian measure that matches it, it would be half of 90. So what's half of pi over 2? Well, you would get pi over 4. And then we can do the same thing for 60 degrees, right? So if this is a 60-degree angle, 60 degrees, you can think of it a couple ways. You can think of it in relationship to 90, like 60 degrees to 90 degrees is like 2/3 of the measurement. I like to think of it as like that 60 degrees is just two 30-degree angles. So if I took 2 times 30 degrees, I would get 60 degrees, right? So for radians, if I took 2 times pi over 6, I should get my radian measure for 60 degrees. So this would give me, well, if I reduce, I would get pi over 3. These measurements are going to be ones that I want us to know and be able to do without a whole lot of trouble. So what we're getting at here is how we measure in radians. So some of the more important measurements, and I'm just going to kind of recap here. We know that 0 degrees is equal to 0 radians. Notice that there's no like unit on here. We don't put radians after it. 360 degrees is going to give me 2 pi radians. So it would look like that. And then we can think about all the quadrantals. The quadrantals are these like 90, 180, 270, right? So 90 we said was pi over 2, 180 was pi, and then 270 was 3 pi over 2. We call these quadrantals because they're like on the quadrants, right? Right between the quadrants. So these are what we call, like, these are kind of our special angles, right? So these are kind of our measurements. Now the ones I want us to add to that are the 30 degrees, the 45 degrees, and the 60 degrees. So I want us to kind of be able to generate or know what these measurements are in radians. So 30 degrees is pi over 6, 40 degrees is pi over 4, and 60 degrees is pi over 3. So the way I memorize this, and again, I think it's easier just to memorize, especially these angles, is the pi over 4 and 45 degrees seems to match, right? Number one, it's half of your 90 degrees. That was one way of looking at it, but also the 4 and the 4, I can just kind of keep that in my brain and think about, okay, those match. The pi over 6 and the pi over 3, they're opposites, right? The 60 degrees has a 3 as a denominator, and the 30 degrees has a 6 as a denominator. So that's kind of how I keep it straight in my brain. You know, you can find something that works too as well, but that's kind of what I'm doing. So that's what a radian measure is. So again, if we go back up to this little circle that I made, this degree here, this measurement here is 30 degrees. The radian measure measures this piece of the circumference. So basically what we're saying with the 30-degree angle in radians is we know that the circumference of a whole circle, at least on a unit circle, is 2 pi times the radius. This is pi 6, in other words, like 1/6 or pi over 6 of your entire circumference. So what we're looking at is just a fraction of the circumference is what you're kind of getting at. We're going to do a lot more with radians, but this is kind of your starting, right? So this is kind of your main points here that we want us to kind of know, what the degrees and radians are. All right, let's go back to this page. So this page was 249. So we talked about what a radian is. It's like so if I look at like kind of like the formal definition, a radian is the measure of the intercepted arc length on a circle. So if you want to write that down, you can. It's the measure of the intercepted arc. My pen's running out. So the measure of the intercepted arc length on a circle. So again, what we're talking about here is the radian. A radian measure is if you have a circle, okay, it's a piece, right? So it's the measure of this intercepted arc. So I know you're kind of going back to your geometry days. An intercepted arc is an angle that intercepts your circle. So it's this piece, or any piece, depending on your angle. So what a sector is, so imagine you have a circle, okay? A sector would be the area, so let's say this is a 45-degree angle here, or in other words, pi over 4. So this measurement is pi over 4 radians. So this would be the radian measure, that's the intersected arc, whereas a sector would be the portion of the area of a circle. So rather than having like the whole area of the circle being pi r squared, this sector would be just like one portion of it. All right, so we talked about angles that are in standard position. Again, that's an angle where the vertex is at the origin, the initial side is the positive x-axis, and then you measure your angle going backwards at counterclockwise, okay? What we're gonna do is we're gonna do a lot more with radians here in a bit, and what I'm gonna have you guys do is we're gonna talk a little bit about coterminal, and then I'm gonna kind of introduce you to the unit circle and then kind of fill some stuff in. So if you haven't already done so, there is this sheet that I have printed on Canvas. It's just a blank unit circle. You don't have to have it. You can always just kind of draw one on a piece of paper. But if you want to print one off, I would encourage you to do so. You can kind of pause the video and do that now. All right, so before we get too far, I wanted to go back to this idea of coterminal, right? So we talked about coterminal angles being, you know, you take an angle. So here's an example. Like if I took an angle and I added 360 degrees, right? So if I took a 100-degree angle and I added 360 degrees, then I know 100 and 460 are coterminal. And I could keep adding 360 degrees to get more and more coterminal angles. Well, you can do the same thing with radian measures. So let's pick a radian. So I don't know, pick one that we know. So let's do 60 degrees, pi over 3. If I wanted to find a coterminal angle for an angle that's measured in radians, rather than adding 360, what do you think I would add? What's the equivalent in radians of 360 degrees? That's like, what's the equivalent for all the way around a circle? Well, yeah, it's 2 pi. So if I'm going to find a coterminal angle for an angle that's in radians, I would just add or subtract 1 revolution, or in other words, add or subtract 2 pi. So you have to do a little bit more work here. If I add 2 pi, remember you have to change your denominators because you're adding fractions here. So instead of calling it 2 pi, call it 6 pi over 3, which is the same thing. And so pi over 3 plus 6 pi over 3 gives me 7 pi over 3. And so what that means is both of those angles are considered coterminal. So what it would look like is if I had a 60-degree angle, okay, so that's 60 degrees, but we're going to call it pi over 3. What 7 pi over 3 would look like is 1 complete revolution around plus that. So that's kind of how you will see it written. You'll see kind of like a whole loop plus like an extra. And so that would represent 7 pi over 3 because it's 1 revolution around plus 60 degrees or plus pi over 3. Again, remember, you can go the opposite direction. If I had pi over 3 and I wanted to find a coterminal angle, but I wanted it to be negative, I could subtract 2 pi. So again, you could find your common denominators, And this time I would get negative 5 pi over 3. So this and this are also coterminal to 7 pi over 3. So graphically what that would look like is, let's say here's my 60 degree or my pi over 3 angle. If I were to go backwards, okay, so negative angle means you're going backwards. This would be negative 5 pi over 3. Or in other words, since this is 60 degrees, this would be negative 300 degrees, right? Because I'm going backwards 300 degrees. Because obviously the whole way around is 360. So that's how you can use coterminal with radian measures as well. All right, if you have your unit circle, grab it. Let's chat a little bit about this. So we're going to get into this, and we're going to talk a lot more about this. Well, we're going to be talking about this a lot. So we'll keep coming back to this, okay? So first thing I want us to kind of add in here, we're just going to kind of add in some stuff, just so that we can kind of fill in some of the blanks here. What I want to start by adding in is, again, understand that when we talk about a unit circle, your radius means, or your radius is 1. So it's 1 unit in length. So keep that in mind for all of these, okay? So what we're going to use is what we talked about in the last video, which is our special right triangles. We're going to talk about a 45 and a 60 degree angle. All of the angles on a unit circle are derived from your special right triangles. So we're not talking about angles like 24 degrees or 192 degrees. We can, but we're not talking about those on the unit circle in particular. So when it comes to a unit circle, we're talking about only special right triangles and then like your major quadrantals. So let's fill in what we know. So do you see these little degree marks? What this means is this represents 0 degrees, right? We're at our imagine your initial sides here, your terminal side is on top of it, it's 0 degrees. Then we're going to add in 90 degrees, 180 degrees, 270 degrees, and notice there's another box here or a little line here. I want you to write 360 degrees. So that's one complete revolution all the way around in degrees. What I want us to do now is add in the rest of the degrees. So what that means is we're going to have 3 different kinds of angles in every one of these quadrants. So remember, if you need some help here, remember to label your quadrants 1, 2, 3, and 4. So in quadrant 1, we're going to talk about that 30 degree angle, a 45 degree angle, and a 60 degree angle. So those are the 3 angles we're going to refer to. What we're going to do is we're going to talk about those same angles. We're going to do a 30 degree angle, a 45 degree angle, and a 60 degree angle, but we're going to talk about them in this quadrant. So what that means is if I'm talking about this angle right here, so imagine I have 180 degrees. So 180 degrees is this straight line. This angle right here matches this 30 degrees angle right here, okay? So that means if I subtract 30 degrees, I would come up with this angle here to be 150. And so what you're really measuring here at 150 is you're measuring this, like this angle right here. You're measuring the initial side here, the terminal side here. This whole angle is 150 degrees. But how we find it is we kind of, what we do is we take, you kind of recognize the fact that this is, you're going to subtract 30, this is where you're going to subtract 45, and then you're going to subtract 60. So this is where those 3 angles are going to come into play. So this angle here is 150, and if I subtract 45, this would be 135. If I subtract 60, this would be 120. So what I call this is a 30 degree angle in quadrant 2. So basically what I did is I took 180 and I subtracted 30 degrees. This is a 45 degree angle in quadrant 2. I took 180 and I subtracted 45. And then this is a 60 degree angle in quadrant 2. I took 180 and I subtracted 60. So that's how I'm generating those angles. So to get to the angles in this quadrant, and sometimes people find this helpful, what you're doing is you're taking 180 and you're subtracting whatever your angle is. That's kind of what you're doing to get to your angles in quadrant 2. You're taking 180 and you're subtracting your angle. 180 minus 30, 180 minus 45, and 180 minus 60. Now the good news is we only have those 3 angles on the unit circle. And so we're really going to only focus on like anything that's a special right triangle. So a 30, 60, 90, a 45, 45, 90. All right, let's do the same thing but in quadrant 3. So in this time, to get to quadrant 3, this is one down here, we would go 180 degrees, but now we're going to add 30 degrees. We're going to add 45 degrees, and we're going to add 60 degrees, because now my angles are 180 plus all of those. So if I added 30 degrees, I get 210. If I add 45, I get 225. If I add 60, I get 240. Okay, so if you wanted to, you could think of it in quadrant 3. You could think of it as 180 degrees and then add your angle. So the angle that I'm referring to here is, we're going to call that a reference angle, and I'll talk about that later. But a reference angle is referring to either the 30, the 60, or the 45, right? So we're taking 180 and we're adding all of those. All right, let's go to quadrant 4. So it's easier to do everything based off of the x-axis. Notice that I started, when I did quadrant 2 angles, I started at the x-axis and I subtracted 30, 60, and 45. And then to get to quadrant 3, I went from the x-axis and I added 30, 60, and 45. On quadrant 4, it's always easier to start with your x-axis. Don't use your y-axis. So again, we're going to think of more. If this is 360, then this angle would be 360 minus 30. This angle right here would be 360 minus 45. And then this angle would be 360 minus 60. So if you think of it as subtraction, it's a little bit easier. So anyway, 360 minus 30 is 330. This would be 315, and this would be 300. So those are all the angles that we're dealing with in degrees on the unit circle. That's it. Let's see if we can fill in some angles in radians now, right? So this is the catch. So the degrees, I'd like you to know, obviously. But so I think most of us find it a little bit easier to deal with degrees than probably radians, because radians is the new thing. All right, let's deal with radians. Let's use what we know, right? So again, remember what a radian is. Oh, I forgot. I wanted to add in the the fourth quadrant, we would take 360 and subtract your angle. So it would be 360 minus theta for that. That's kind of how we generated those angles. All right, so let's fill in the radians we've already talked about. So at 0 degrees, we have 0 radians. And again, you don't need to put a symbol or anything after it. All the way around, at 360 degrees, we would have 2 pi radians. Trig is a lot about fractions, and so that's what we're kind of doing here. We're dividing this up. So again, what we talked about before is then halfway around, all the way around is 2 pi, halfway around is pi. And then half of pi would be pi over 2. And so then if this is 0, 1/2 pi, 1 pi, this would be 1.5 pi. So how you're going to see that written is 3 pi over 2. So those are all of our radian measures. We call these angles, the ones that fall right on the quadrants, we call those quadrantals. We'll talk a little bit more about those later, but those are just angles that fall right on the quadrants. All right, next we're going to talk about our 30, our 60, and our 45. So if you remember, 30-degree angle, they all have to do with pi here. 30-degree angle is going to be pi over 6, remember, because it's the opposite. The 60-degree angle is the pi over 3, and the 45-degree angle is the pi over 4. Okay, so those are the 3 kind of baseline angles that we need. The rest of this, how we're going to fill the angles in all of these other quadrants, are based on exactly what we just did. So remember how we figured out these angles here? We took 180 and we subtracted 30. We subtracted 60 and we subtracted 45. That's the exact same thing we're going to do, but we're going to talk about radians. So we're going to take pi and we're going to subtract 30. In other words, pi over 6. We're going to take pi and we're going to subtract 45, or in other words, pi over 4. And we're going to take pi and we're going to subtract 60 degrees, which is pi over 3. So to get the angles in the second quadrant here, we're going to start with pi. So pi minus pi over 6, that would give me my 30-degree angle. So it's easier to think of pi, instead of thinking of it as pi, think of it as 6 pi over 6, right? Have the same denominator. 6 pi over 6 is still the same measurement as pi is, right? We just scaled it up. So that means if this is pi, and then we subtract 30 degrees, we subtract pi over 6, this would give me 5 pi over 6. Okay? Then if I took pi and I subtracted 45 degrees, so pi minus 45 degrees, so in other words, pi minus pi over 4. So let's change that to 4 pi over 4, so they have the same denominator. This would be 3 pi over 4. Okay, same thing here. Now let's take pi and let's subtract 60 degrees, which is pi over 3. So change this so they have the same denominator. This would be 2 pi over 3. What I want you to recognize is the fact that anything to do with a 30-degree angle, so like the 30-degree angle in quadrant 1, the 30-degree angle in quadrant 2, in radians, notice their denominator is both 6. Notice the 5-degree angles have a denominator of 4, and the 60-degree angles have a denominator of 3. That's going to come in handy, okay? So to recognize that. All right. We're going to follow that same strategy, and we're going to go to quadrant 3. So we're going to take pi. This time we're going to add. So we're going to take pi and we're going to add 30 degrees. We're going to take pi, we're going to add 45 degrees, and we're going to take pi and we're going to add 60 degrees. So that's kind of what the math we're doing here. So again, I'm going to make these common denominators because I can. And so I get 7 pi over 6, this would be 5 pi over 4, and this would be 4 pi over 3. So in quadrant 3, I would get 7 pi over 6. Again, notice the denominator is 6. This would be 5 pi over 4, and then 4 pi over 3. All right. Same deal. In quadrant 4, remember what we did? We took 60 and we subtracted pi. So same deal that I'm going to do here. So I'm going to take 2 pi, which is 360, and I'm going to subtract 30 degrees, or pi over 6. I'm going to subtract 45 degrees, or pi over 4. And I'm going to subtract 60 degrees, which is pi over 3. So again, change your denominators. So I want this to have a denominator of 6, so I need this to be 12 pi over 6. Right? So you're doing fractions. We're changing pi over 2, or 2 pi over 1 to 12 pi over 6. Both gives me 2 pi. So I'm going to do this one. I'm going to change this to have a denominator of 4. So this would be 8 pi over 4, which would be the same thing as 2 pi, minus pi over 4 would give me 7 pi over 4. And then to have a denominator of 3, this would be 6 pi over 3, minus pi over 3 would give me 5 pi over 3. So those are the measurements we're going to use in this quadrant. So the 30-degree angle will have a denominator of 6, so 11 pi over 6. This one would have a denominator of 4, and this one has a denominator of 3. So again, all of the 30-degree angles in all quadrants have a denominator of 6. All the 45 have a denominator of 4, and all of the 60 have a denominator of 3. So all we're really doing here is, again, same kind of deal. To get angles in the fourth quadrant, we're taking 360 and we're subtracting pi. If you want to write that in, I'm saying, taking 360 and subtracting your angle. In radians, it would be the same deal. You're taking 2 pi and subtracting your angle. You're taking pi in quadrant 3 and adding your angle. You're taking pi and you're subtracting your angle to get to quadrant 2. So that's how we're going to generate all of these angles on the unit circle. We're going to use these a lot, so they're going to come in handy. Don't worry about memorizing this unit circle. What I want us to get in the habit of doing is kind of thinking about, radian measures. So for example, let's cover up the unit circle, and I say, what is, let's say, what is 5 pi over 4? What quadrant is 5 pi over 4 in? What I want you to kind of think about is this. Okay, so first of all, do you recognize, because of this denominator, we're talking about a 45-degree angle? Okay, that's going to come in handy later. The other thing I want you to realize is 5 pi over 4, think about 5/4. 5/4 is 1 and 1/4 pi. So if you know that here's 1 pi, 1/4 pi would land me here. So 5 pi over 4 would be in quadrant 3. Let's do another one. What if I did 2 pi over 3? Okay, so again, do you recognize that with a denominator of 3, that means we're talking about a 60-degree angle? 2 pi over 3, 2/3 of a pi. That's less than 1 pi. So 2/3 of a pi. Here's half a pi. Here's a whole pi. So 2/3 of a pi, 2/3 pi, would land you in quadrant 2. What I want us to get in the habit of doing is recognizing kind of how to write these angles in, like how to read radian measures, and think about it as how many pies, because we know this is 0, this is pi, like this is 1 pi, and we know all the way around is 2 pi. So if we're given a radian measure like 11 pi over 6, we know that that is 11 out of 6, so that is 1 in 5/6 pies. So 1 in 5/6 would land me in quadrant 4. That's where we're going to kind of be going with all of this. Okay. I know this is a long video, but there's just a lot of content, and so I apologize for the length, but unfortunately we're going to keep going. We're going to go to page 251, and I just want you to look at some of these. We're not going to do all of these, and this is the last thing we're going to do. So what I'm trying to get you to do is, this is kind of the basics of what I want you to be able to do. Can you draw an angle with the given measure? So notice these are in degrees. Can you find a negative coterminal angle and a positive coterminal angle? And then can you convert between radians and degrees? So for these ones, like negative 750 degrees, how I would do this one is, if I said this is negative 750 degrees, I would always I would rewrite it as an angle between 0 and 360, because we're more comfortable dealing with angles between 0 and 360. So if I did this, what is this? 390. So that would be negative 390. Then I'm going to add 360 again, and this would be negative 30. So you can think of it as negative 30, or you can keep adding 360 till you get a positive answer. So what I'm just doing here is I'm taking negative 750 degrees, and I'm seeing how many revolutions is it. And so negative 360 means I'm going to go backwards 3 times around the unit circle, and then I'm going to end at 330 degrees. So it would look like this. Negative 750 means I'm going backwards once, going backwards twice, going backwards 3 times, and now I'm going to end at 330 degrees, which means I'm going to end here. That's how you would kind of write that angle in standard position. I want to see how many revolutions, backwards or forwards, you're going. And so that, and then this is kind of where your ending spot is. So that's kind of how you would write it. It looks a little weird, and it does take a little time to get used to it. But remember, this is, you want to show how many revolutions around it goes. We've talked about negative and positive, coterminals. So again, all you're really doing here is you're taking and you're either adding 360 to get a coterminal angle, or you're subtracting. Now you can add multiple, I normally just do one, add 360 or subtract 360, but you could add 360 and then add 360 again to get a different angle. It's really up to you. What I wanted to talk about before we're done with this video is this last piece here. So I've talked a lot about in the radian measures for angles that were on the unit circle. So again, just to kind of recap, the angles that were on the unit circle, let me grab my unit circle here. Angles that were on the unit circle all dealt with either 30, 45, 60, or they were one of your 4 quadrants, right? Well, there are other angles in the world that don't that aren't 45, 30 degrees or 60 degrees or one of those quadrantals. We could have, for example, 310 degrees. That's an angle that's not on our unit circle. However, we can still write it as a radian. And so the conversion rate is, if you're going from degree, and I'm just going to write this down, to radians, what you do is you multiply by pi over 180. So if I'm taking my angle and it's in degrees, so negative 310 degrees, and I want to write it in radians, I would multiply it by pi over 180. And then you would just reduce the fraction. So you would get negative 310 pi over 180, reduce negative 310 over 180. The easiest way to do that is to go negative 310 divided by 180 in your calculator, and then hit math, enter, enter, and it gives you the reduced fraction. Now, of course, you can do it in your head, of course. So I get negative 31 pi over 18. You will always, I shouldn't say always, you will generally have the directions where it will say leave your answer in degree or in pi, like in terms of pi. That just means don't multiply by pi. If you're given a radian measure, so you don't see any degree symbols here, right? So this is a radian measure. To go from radians back to degrees, you do the exact opposite. So if we multiplied by pi over 180, going from degrees to radians, to go from radians to degrees, we multiply by 180 over pi. And the reason why is so that this pi and this pi cancel each other out. And so then you get 16 times 180 on a numerator and get 2,880 over 15. And so this would equal 192 degrees. I rarely use these conversions. And the reason why is because mostly in this class, we're going to be dealing with angles that are on the unit circle. And I would rather you not do the conversions back and forth. But I wanted to show it to you just so that you saw it, that there are other angles that are not on the unit circle, that this is how you would convert from radians to degrees. So rather than thinking of it as like a fraction of the circle, right, that 30 degrees is 1/3 of 90, and so therefore 1/3 of pi over 2 is pi over 6. Rather than thinking of it as fractions, the conversion is just, multiply by pi over 180 or multiply by 180 over pi, depending on which direction you're going to go. However, every angle that we're going to be dealing with on the unit circle, I want us to think in terms of what piece of the circle it's representing. Like, I want you to represent that pi over 6 as representing, 1/6 of 180 degrees. Because it's important that we understand the fractional part about that. So the less we do the conversions, the more we're forcing our brains to kind of think in those terms. All right, a long video today. I apologize. Lots of good stuff in trig units. If you have, I would practice. If you have any questions, bring them to class. All right, bye for now.